looking at example 2, it says subtract. Okay, and again, the book might still say add. Again, algebra books, adding and subtracting, they're all in the same family, so they sometimes will say add. But notice this is minus, we're subtracting polynomial 1 minus polynomial 2. And again, there's nothing happening to polynomial 1. Here's polynomial 1. And also notice the powers of x and y. There's x's and y's and so on and so forth. This will be a little bit more difficult to get into some sort of descending order. So I'm just going to say the first order is going to be the order I'm going to work with. I'm going to get the other one lined up the same way. So if I see like terms, I'll put them in the proper position based on the original polynomial. So I'm going to call the first polynomial the original, the first polynomial. So it's positive, all this stuff. There's no sign over here affecting the signs, so all the signs are what they should be. So the parentheses are there for effect only, just to say this is a polynomial that we're subtracting from that polynomial. So the first one's going to be positive 3x squared y squared plus 2xy squared plus 6x squared. Before I go any further and deal with the second polynomial, in order to add letters, you have to have the exact same letters raised to exactly the same powers in each term to be able to add them together. So if I investigate these terms in this blue polynomial I've got written down here, can we all see this has both x and y in it, so does this? So they're candidates for possibly being like terms. Maybe we can add them together, but all the powers have to match exactly. Y squared and y squared are the same power, x and x squared are not. So since the powers don't match on all the letters, adding those is illegal. We cannot do it. And then if we look at then this term, 6x squared, well this has x squared in it also, but this doesn't have y squared, this does, so those aren't like terms either. So when we're considering what like terms are, what like terms aren't, the letters and the powers have to match. So even though those are both x squared, this has y squared, that doesn't, they're not like terms. Even though these both have x and y, this is x the first, that's x the second, they're not like terms. You cannot add them or subtract them. So that first polynomial is as simple as it can get. All simple means that you can't do anything else to it. Now, we have this minus sign in front of the second parenthesis, so I'm going to subtract each individual object, and I want to line up like terms as I do it. If I don't have a like term, I make up a new column. So I'm going to get minus 32y squared. Is there any other y squared object here? Just y squared, nothing but y squared? No. So I'm going to make a new column for that. So minus 32y squared, I'm just going to throw over here. Doesn't matter where you put it, because again, we've got two different letters here. Getting some sort of descending order is not going to be very easy to do, or even meaningful really, because it's all over the place. I'm going to be subtracting minus the second object. It's going to be plus 3xy squared, which matches up. Oh, sorry, minus plus, right? Minus plus is going to be minus 3xy squared. We're subtracting a positive, which makes a negative. And then we're subtracting negative 2x squared, which is going to be positive 2x squared. So notice what the minus sign outside the parentheses did to the three objects inside. 32y squared became negative, 3xy squared became negative, negative 2x squared became positive. All right, so that's all the minus sign in front does. And again, the word in the problem says subtract. It very clearly says subtract. Once you change the signs to what they're supposed to be, you've officially subtracted. Now you have to make a decision, add or subtract based on the signs within the problem you're doing. All right? And notice, as I wrote the answers down, if I saw a like term, I lined them up. So this has xy squared, this has xy squared. Those are both like terms. This has just x squared, this has just x squared. Those are like terms. All right? So at this point, I'm going to either add or subtract each column, or just move it down if there's nothing new to go with it. So nothing's with 3x squared y squared, nothing happens with 3x squared y squared. It's positive, it stays positive, nothing at all happens. These signs are different, so I subtract. I'm going to get 1xy squared. 3 is bigger than 2, so it's negative. So again, when I'm dealing with two numbers at a time, if the signs are different, I subtract. The bigger number is the sign of the answer. If the signs are the same, I add. The bigger number is the sign of the answer. The 1 is optional. If you put minus xy squared or minus 1xy squared, they mean the same thing. So if you put the 1, don't put the 1, they mean the same thing. So I put the 1, I'm going to leave it. 6x squared and 2x squared. 6 plus 2 is 8. They're both positive, so I add. 6 is bigger, so it's positive. And they're both x squared terms, so I get x squared. Again, Powers don't change. X squared, x squared, x squared, we change the coefficient, the number in front. 6 plus 2 is 8.
I thought we had to subtract that one.
Say again?
I thought we had to subtract everything.
Okay, again, once we did minus and changed all the signs where they belonged, at that point we have to make an add or subtract decision based on the signs we're dealing with. All right? So in this problem here, 6 and 2 are both positive, same sign I'm going to add. 2 and 3 different signs I subtract. So when you make that decision, should I add or subtract? Again, don't get hung up on the word add and subtract in the problem.
And so say if they had like terms in that same sentence, we can combine those and then do the other.
Yeah, if there have to be like terms in here, you could have combined those before you did everything else. Yes, that would be legal. All right, and then finally, minus 32y squared is not being combined with anything, so nothing happens to it. So minus 32y squared is our last term. All right, so the difference is that 3x squared y squared minus 1xy squared plus 8x squared minus 32y squared. All right, so that's the answer to the subtract problem. All right, as far as degree is concerned, okay. First term has two variables x and y. The powers are 2 and 2. We add those powers up. 2 plus 2 is 4. So that degree is 4. The second term has two letters, x and y. The powers are 1 and 2. 1 plus 2 is 3. 4 is still bigger, right? The third term, 8x squared only has one letter, x. Its power is 2, so the degree of that's 2. And the last term, negative 32y squared, has one letter, y. Its power is 2, so the degree is 2. So we have degree 4, degree 3, degree 2, degree 2. Again, that's what, when you find a degree of a polynomial, just find each individual degree first. The biggest one, which is 4, is the right answer. So I would say degree equals 4. Degree is more of a mental exercise than anything. You have to add a couple numbers, but mostly you're finding the biggest one. So what's the biggest one? 4, 3, 2, 1, 4 is the biggest. That's the answer. I would expect you to do degree that way on your homework if asked. I don't need to see that you figured out each individual degree. I'll believe you did it if you got the highest one.